I'm going to introduce Dr. Linda Nagel. She's a professor of silviculture and the department head of Forest and Rangeland Stewardship at Colorado State University. She directed and taught local and national modules for the U.S. Forest Service National Advanced Silvicultural Programs for 15 years. And she's currently serves as the national lead for the Adaptive Silviculture for Climate Change Network. So take it away, Dr. Nagel.
Great, thank you, Paul. And do you see full screen? Good to go?
Yep.
Excellent, thank you. Thank you for that introduction and for the invitation to come here and speak today. I'm speaking from Fort Collins, Colorado, and I would like to recognize the original stewards of this land by reading the Colorado State University Land Acknowledgement Statement, which also identifies a critical role for academic institutions. Colorado State University acknowledges with respect that the land we are on today is the traditional and ancestral homelands of the Arapaho, Cheyenne, and Ute nations and peoples. This was also a site of trade, gathering, and healing for numerous other Native tribes. We recognize the indigenous peoples as original stewards of this land and all the relatives within it. As these words of acknowledgement are spoken and heard, the ties nations have to their traditional homelands are renewed and reaffirmed. CSU is founded as a land-grant institution, and we accept that our mission must encompass access to education and inclusion. And significantly, that our founding came at a dire cost to Native nations and peoples whose land this university was built upon. This acknowledgement is the education and inclusion we must practice in recognizing our institutional history, responsibility, and commitment. These land acknowledgement statements by universities are the very first seeds toward much greater work that is needed at institutions of higher education, especially land-grant institutions. Today, I'm honored to be here to share with you some work that I've been engaged with for the last 15 years under the umbrella of Managing for the Future through Adaptive Silviculture for Climate Change. To start us off, a global context. This is a map of forest types around the world, and forests are incredibly important globally. And the map also shows different biome types. So across North America, as Paul was just suggesting, we have great diversity of forests. We have boreal forests, temperate forests, subtropical and tropical forests. And the little graphic at the bottom shows the top 5 countries of forest area across the globe. So this is a really exciting meeting to be engaged with, and it's going to be really fun to hear the different perspectives from folks all across North America. So forests are incredibly important. We all know that. That's one reason why we're all here attending this conference, but they're also under a great deal of change right now. So forests provide us with essential ecosystem services, provisioning, regulating, supporting, and cultural services. And in addition to material benefits, there's a growing recognition of the cultural and spiritual importance that forests provide for many, many people. Global change is creating an increasingly dynamic and uncertain future. And contemporary disturbances that we have across the landscape are often becoming more catastrophic, more frequent, and are sometimes repeating. And there's implications on forest sustainability and recovery following these disturbances. And I'll be spending a little bit of time talking about that. We also have a legacy of land use and fire suppression in the recent past that is impacting our forests today, and a changing societal expectation of forests. And that's certainly the case here in Colorado, where I'm speaking to you from. So climate adaptation will be key to a sustainable future, undoubtedly. So what I plan to do today is talk a little bit about disturbances in a case study context of Colorado forests. And I wanted to start with a broader context of the Western United States around drought. So drought cycles have always been a part of Western landscapes, but their frequency, duration, and severity of these events are amplifying other disturbances. This graphic here was published a week or so ago in the New York Times. And it's basically a set of maps that show drought conditions across the West from 2021 back to the year 2000. And this demonstrates that as of June 1st in 2021, a quarter of the United States, a quarter of the Western United States is experiencing an exceptional drought, which is more than twice the area of any period at that level in the last decade. And the hottest months are yet to come. So we're all sort of anticipating the impacts that these recurring and extensive droughts are going to have on forest dynamics, on forest recovery, on the potential loss of crops and pasture land, the impacts to fire risk, water shortages, record low reservoir levels, impacts on energy production, and particularly with forests, we're very concerned about the potential impact on the fire outlook for this year, which was in one of these articles said as bad as it can be. So let's transition and talk a little bit about forest types in Colorado. So here we have two elevational gradients. There's great diversity in forests in the Rocky Mountains due to topography and precipitation and elevation. And so we have a gradient here of different forest types, and all of these forest types in the Rocky Mountains in Colorado also experience fire, and they experience fire in different ways. And so I'll walk you through a couple of important forest types and then relate that back to other disturbances. So here we have Ponderosa pine and Douglas fir mixed conifer forest types. And the Ponderosa pine forest type in particular, which is typically dominated by Ponderosa pine, but also has other species like Douglas fir, aspen, juniper, white fir, and gamble oak, has historically had a frequent fire regime that is low to moderate severity with small patches of stand replacing fire. And Douglas fir, more Douglas fir dominated mixed conifer, which is a bit wetter, has a mix of species as well with semi-frequent fire regime, 20 to 100 years, with moderate severity and patches of stand replacing fire. But in recent time, we have some land use related to grazing, logging, and fire suppression that has resulted in very dense forests. And so the fire regime and the response of these forests has been very different in recent past. These graphics, I want to give credit to the Colorado Forest Restoration Institute, which is housed at Colorado State University. If we move up in elevation, we approach the lodgepole and subalpine forest types. And here we have lodgepole dominated forests and subalpine and Engelmann spruce dominated forests. And both of these forest types experience infrequent fires ranging from 75 to 300 for lodgepole and 100 to 600 year fire return interval for subalpine and Engelmann spruce. Both of these disturbance regimes tend to be stand replacing, so longer fire return interval and stand replacing. So very different fire regimes and vegetation responses. Okay, so let's talk about some recent fires in this landscape. So this is a map on the right that shows recent wildfires in that Ponderosa pine and dry mixed conifer forest type. And these are ranging from the 80s all the way to basically present day. So these are some of the more prominent wildfires. Some of them have become more severe, as I mentioned, due to some of those land use legacies. And this is causing a lack of regeneration in some of those areas. Between the years 2000 and 2010, only 1 year did Colorado exceed a 100,000 acre fire, and that was in 2002. The Hayman fire in 2002 was greater than 100,000 acres, and that year there was a total of about 340,000 acres that were burned in the state of Colorado. So the year 2020 was a record-breaking year for Colorado. We had 3 fires that exceeded 100,000 acres last year. And so, you know, this was of great concern as we experienced this fire year. There was a drought preceding the fire, and there's also some additional disturbances that impacted the way these fires behaved. And so, just on the right-hand side of this map, you can see that there's an urban area. So that's the Front Range running along the right side of that map. So this is just the northwest portion of Colorado. So these were some really notable high impact fires. So some other disturbances that are really important in this landscape are beetles. So here we have mountain pine beetle activity on the left and spruce beetle activity on the right. And you can see the distribution, the mountain pine beetle distribution. There's the brown color in that map, and the spruce beetle distribution is the colors on the right-hand map. And then you can see some photographs of the impacts of those disturbances. Since the mid-1990s, mountain pine beetle has impacted roughly 80% or 3.4 million acres of Ponderosa pine and lodgepole pine forests in the state, while the spruce beetle has caused tree mortality in approximately 40% of Colorado's high elevation Engelmann spruce forests. So this graphic here shows the thousands of acres that have been impacted on an annual basis by both mountain pine beetle and the spruce beetle. So you can see that the distribution across the landscape of this particular disturbance is very, very high. And as we think about what a forest looks like following a mountain pine beetle or spruce beetle impact, it rearranges the fuels that are occurring across that landscape. And that has huge implications for fire. So this map is showing the fires from 2020 overlaid on top of the spruce beetle map that I showed earlier in the dark color, the mountain pine beetle impacted areas shown in gray. And then the green areas are spruce fir and pine forests that have been unimpacted by pine beetles. And so here you can see that these overlay on top of one another. These represent compound disturbances, and they are happening synergistically across the landscape. And the impact of drought or the relationship of drought with beetles and fire becomes very concerning as we consider these disturbances across the landscape and the impacts on forest regeneration following. This graphic comes from a paper by Connie Millar and Nathan Stevenson in 2015, where they talk about megadisturbances. So climate change is intensifying our drought conditions, it's altering the life cycles of pests and pathogens, and it's lengthening the fire season. And in some cases, the response one on the left-hand side of this graphic shows a forest that can experience these different disturbances, a drought, a fire, a mountain pine beetle or spruce beetle attack, but it can sustain itself. It has resiliency within that system, and it can maintain that forest type. But we have these mega disturbances, these disturbances that are building upon one another. The management legacies that we have across the landscape are exceptional droughts and anthropogenic stressors that in some cases are resulting in forests that are losing that forest type over time. And so response 2 and 3 represent a forest where we have these disturbances that are acting on the forest, and the resulting forest that comes back or regenerates might be a different forest than was there previously. The extreme case, response number 4, is when we have disturbance-driven response where we do not have forest regenerating back following that disturbance. And a very broad generalization across Western North America is that bioclimatic models suggest that forested areas will have a climate and a fire regime that is much more conducive to drier forest types and non-forest conditions. And this may result by the year 2100 in great reductions in forest types across the Western United States, as well as parts of Canada. So in summary, disturbances are having a huge impact on our landscapes. Many areas are experiencing compound disturbances or mega disturbances, and these are a result of a changing climate, more exceptional droughts, insects and pathogens, fire, and sometimes repeated fire, and increasing frequency, extent, and severity of these disturbances. In Colorado forests, we're observing post-disturbance regeneration and recovery is sometimes taking decades or even longer, or not occurring at all due to a combination of a decrease in precipitation, these increased temperatures, possibly losing seed sources, not having a buffering microclimate due to a lack of overstory, and competing vegetation may come in and occupy the site, shrubs and whatnot, and prevent trees from regenerating. We also have a changing societal demand and a growing population, and this is particularly true in the state of Colorado, and that's putting more pressure on our forests. So what to do about these issues? So here's where I want to talk a little bit about a project I've been engaged with for about 12 or 15 years called the Adaptive Silviculture for Climate Change Network. And this really initiated following a need identified by the U.S. Forest Service to take some adaptation principles, design some experiments and some demonstrations on the ground to inform management decisions and to help forest managers see what adaptation might look like, particularly in response to climate change. So this is a map of a current map of our sites. We have 10 sites that we've developed through. Some of them are implemented and some of them are still in the planning phases, and one that we're developing over the summer. And we have a leadership team you can see on the right-hand side of the map here, and we coordinate this network. Each one of these sites and pin drops on the map also has a site team that's made up of scientists and managers that are overseeing these implementations at each of their sites. And so this is a network of sites that are designed to test different adaptation principles. To do this, to develop this study, we are working with the Northern Institute of Applied Climate Science, and we use their climate adaptation framework, which looks very much like an adaptive management framework, where we're defining an area, we're taking information about climate vulnerability at a local ecosystem type, we're evaluating management objectives and thinking about desired future conditions, we're identifying and implementing adaptation approaches and tactics, and then developing a monitoring protocol to learn from the treatments as they are implemented on the ground. So the Adaptive Silviculture for Climate Change project is testing a spectrum of adaptation options where we're considering our current condition and then developing a desired future condition for each of these three adaptation approaches: resistance, resilience, and transition. And in the resistance treatments, these are actions that are really designed to improve the defenses of the forest against change. But the goal here is to basically maintain the forest as it is, so managing for persistence. The resilience treatment is basically how well that ecosystem bounces back from a disturbance. So here we're talking about the capacity to absorb disturbance and recover to a prior condition, whether that is the current condition or a pre-established condition. So we're accommodating some degree of change, but still wanting to return basically back to an ecosystem that once was. The transition treatment is the one where these actions are intentionally designed to accommodate change or to facilitate change. So these ecosystems may have fundamentally different structure and character compared to the current condition that we're starting with. So it's also helpful to think about adaptation strategies, and this is from the same framework by the NIACS group. And there's 10 strategies here listed along a spectrum of resistance, resilience, and transition. And these are not mutually exclusive. So many strategies meet multiple, if not all, of the adaptation goals. So for instance, sustaining fundamental ecological functions of forest ecosystems is a goal for resistance, resilience, and transition in how we're using these terms in this study. So you can see that there's a nice list of potential strategies here that cover things like maintaining and enhancing species and structural diversity, promoting landscape connectivity. And these are also very complementary to other approaches to forest management, like ecological silviculture or managing for complexity. So diversity and complexity are both really critical ecosystem functions in this study. So this is a collaborative study, a collaborative project. We design these treatments at an individual site through a collaborative workshop where we discuss resistance, resilience, and transition. We have an experimental framework and design of minimum replication and size. And then we have site-specific treatments that we design and a monitoring protocol that's specific to each of those sites as well. So I want to briefly compare and contrast three of these. We're going to look at two sites in Colorado and then the site in British Columbia. And this is going to relate back to the disturbance types that I talked about earlier. So the San Juan National Forest is a warm, dry mixed conifer forest type with climate concerns that include warming, variable precipitation, mostly drying, earlier snowmelt, and an increased risk of wildfire and insect outbreaks. Here we have typically a frequent fire regime, but we have had many decades of fire suppression. And so we have that sort of built up fuel loading in this particular site. We did this workshop on the San Juan in 2014, and this is projected to be harvested this coming year over the next couple of years. So just briefly walking through this, our current condition, there's a picture there at the very top. Our resistance treatment in this case was to reduce stand density along a fairly even spacing. The resilience treatment was to create a more heterogeneous structure, to reduce the density, but to really create a clumpy, gappy opening type of structure within that forest to break up the fuel loading, but to also increase the drought tolerant species on the site, or the proportion of them. And then the transition treatment is really focused on more open conditions where we have 30 to 40% openings and increasing the drought and fire tolerant species as well. Here where the prescription calls for retaining ponderosa pine, aspen and clumps, and removing all white fir. With this one, the group was willing to accept that the forest may transition to a more non-forested or woodland type of condition. So this was a real challenge for the group to consider these treatments. The second site I want to talk about is the Colorado State Forest, which is in a high elevation forest type, so lodgepole pine and Engelmann spruce dominated. Here we're concerned about warming conditions, lower precipitation, earlier snowmelt. And we have variable topography and soils across the site, and the area has been deeply impacted by spruce and mountain pine beetle. This site was actually just a very small portion of it was burned by the Cameron Peak fire last year, but it's basically on the other side of the Continental Divide. So this fire regime historically was infrequent fire in this forest type. And we have, because of that beetle impact, we have a high fuel loading here as well. So these treatments, the resistance treatment is to reduce stand density. I apologize, there's a truck driving by my window. The resistance treatment was to reduce stand density, release the advanced regeneration, and to basically work with the species that are on site. The resilience and the transition treatments both involve basically variations of group selection to create heterogeneous structures, to focus on different species, so increasing drought tolerant species and genotypes. And then the transition treatment is where we're still contemplating future adapted species, including some that may not exist on the site today. And so this is an example of potential forest assisted migration and a conversion type to an upper montane forest. And the last site that I'll talk about very briefly is the John Prince Research Forest in British Columbia. So you can see this map of British Columbia shows a distribution of merchantable forest volume that has been killed by beetles. And then there's some fire perimeters from 2017 and 2018. So a landscape that's been deeply impacted by disturbances that are very similar to the disturbances I described in Colorado. So the John Prince Forest is a 16,000 hectare area that is managed collaboratively through a nonprofit corporation that's jointly owned by the University of Northern British Columbia and the Gladstone First Nations. And this is a partnership that was formed about 28 years ago. And
2 minutes left.
Thank you, Paul. And this was to promote natural resource research and education that demonstrates innovative, sustainable natural resource management through the integration of traditional and Western science and the recognition of diverse cultural values. So the Gladstone Nation has a land use plan that was derived from a land use study. It is based on family-based resource management areas, which are basically like watersheds, and it incorporates a lot of cultural values. So here we have some beautiful pictures of different cultural values that are incredibly important to this landscape and to the people, including moose habitat, fisheries, and water. So this is a subboreal spruce bioclimatic zone. It's dominated by Douglas fir, spruce, subalpine fir, lodgepole pine, and aspen. So again, some common species here. The map on the right, there's little dots there, and that represents all the treatment units that have been identified to be part of this study, which is about 200 hectares in size there. So here we also have some disturbances, including fire and mountain pine beetle. And 98% of those disturbances are stand replacing. So we just completed this workshop about 2 weeks ago. These treatments are still in draft form, but I wanted to show you that here this group really is embracing some forward-looking forest management practices. All of these treatments involve creating some types of openings and heterogeneous structures, and they are contemplating increasing species diversity across these landscapes, including potentially planting some species that don't currently exist on this site. Okay, so just some quick trends here. As we work across these treatments, across all of these sites, there are some concepts that were pretty consistent. We considered historic range of variability in determining desired future conditions and identifying silvicultural practices. As we worked across resistance, resilience, and transition, we saw an increased emphasis on species diversity, complexity, multi-age silviculture, and consideration of future and novel species for the sites. And so those are some of the practices that really emerged. I will skip this slide and wrap up, but this is a study that's really designed to address high impact cross-site research questions that are centered on climate adaptive management, including which of these treatments perform best, which ones maintain forest cover over time. We have built something where we can look at the success of native versus novel species. We can really contemplate some of these theories around ecological transformation, and then also what are the responses to large-scale disturbances in different forest types over time. So with that, I will wrap up and hand it back over to Paul.
Thanks so much, Linda. I think we have time for one or two quick questions. If there's something on your mind to ask Linda now, or write it down and we'll come back to it later in the panel discussion. So thoughts, reflections, she covered a lot of ground there, folks. If there's not something readily apparent, I'd like to ask a little bit about the adaptive monitoring strategy, because it's something I'm very interested in and feeding into the various sites. And if you could maybe talk just a little bit more about the monitoring process.
Yeah, so we have a basic plot design that we're asking all of the sites to utilize that allows people to measure both the understory and the overstory vegetation to get an indicator of forest health. And those are really very site-specific or regionally specific metrics. The idea is that we will collect enough data across all of the sites in some level of uniformity that down the road we can do cross-site comparisons with that data, but there is some site-specific specificity to how those monitoring protocols are designed. So we're interested in good pre-treatment data as well as, post-treatment 1, 3, 5 years following treatment. There's a minimum of 7 plots per treatment unit. Each of the treatments are replicated 4 times at each of the sites. So we have some statistical robustness across each of the individual sites. So an individual site will be able to collect data and draw their own conclusions. But the idea is that down the road, we'll be able to combine data and look across site at some of these questions.
Okay, it looks like we do have a couple of questions. Lisa, do you want to read those? We have time for about one.
I am not seeing those questions yet. It's
in the question and answer pod.
One of them, I'm going to have to move on, but one of them refers to basically, Linda, where can they find more info? And if you could put a link to the Adaptive Silviculture for Climate Change Network up in the chat, that would be super helpful. And I encourage other speakers to do the same so they can find your work. But actually, we have to kind of move to the next speaker now. And we'll get the rhythm of this, folks. So give us a little time. But let's give Linda a virtual hand. So thanks so much, Linda, and please put up your contact information or a link to that site if you would.
Will do.